Let's take a look at Project 3, Part 2 for Algebra 2b. So this section is all about transformations. Our first question is, what happens to the graph of a function when it is transformed by translation? So a quick recap on translation. Remember that translation is movement that changes our location on the xy plane. So for example, if I had some triangle down here and I decided to translate it 5 units up and 7 units to the right, and now it's here, right? This is a translation. In fact, let me pull up a graphing tool and show you a better picture. So if I had some polygon, right? If I have some triangle and I decide to take that triangle and move it either up, down, left, or right in my plane, this is translation. So you can see I'm moving the figure to the right, that's translation. Moving it left, that's translation. Moving it down, moving it up, or any combination of any of that, okay? So I can move it right and then down, that's a translation. I can move it down and then left, that's translation. Okay, again, any movement, I'm basically sliding the figure, as you can see. I'm kind of sliding the figure around the plane. So any of this is going to be translation. So you have to figure out what that means as far as what we're doing to shape, size, and position. So even going back to this really basic picture I've drawn, are we keeping the shape the same? Are we keeping the size the same? Are we keeping the position the same? Are we keeping the orientation the same? So when you can just write or answer those questions for yourself, you'll easily be able to select the answer option for this question. The next question asks us, which mapping statement represents transformations that include a reflection in either the x or y axis? So in order to know this, we need to know what the mapping statement of a reflection looks like. So if I have, this is our kind of standard mapping statement, f of x, y, and then we say maps to, this arrow is read as maps to, this would be an example of a mapping statement that undergoes no transformation, okay? So you can see f of xy maps to f of xy. This would be the same figure. No transformation has taken place. In the last slide, we talked about translation, for example. That would look something like this. If I wanted to look at that mapping statement, it might be f of xy. Say I wanted to move the figure down 5. It might look like this, where I would have f of xy maps to f of xy minus 5. Okay, so this mapping statement is telling me that I'm going to take some object, some function, whatever, all of its xy coordinates. I'm going to leave the xy coordinates alone. Notice that nothing has been done to my x. But I'm going to take all my y coordinates and I'm going to subtract 5 from them, and that's going to give me a transformation of moving 5 units down. Okay, but for this question, we are talking about reflection. So I know you guys know what reflection is, but let's go ahead and just take a look at it all the same. Let me get rid of my old example, and we'll take a look at reflection. So once again, I'm just going to draw a random shape here. All right, let's say that's my shape. If I wanted to reflect it, across, let's say the y-axis, for example, if I take this figure and I reflect it across the y-axis, okay, notice what has happened. All of the y values are in the same exact spot. If I look at this point A, the y value for this is 7.59. If I look at this point A prime, the coordinate of the image, this y coordinate is still 7.95. If I look at point B, its y coordinate is 4.66. If I look at B prime, its y coordinate is 4.66, right? Let's keep going. C, the y coordinate is 2.24. C prime, 2.24, right? Again, if I look at any y coordinate, of the pre-image, the figure before it's transformed, and I compare that to the y-coordinate of the corresponding point in the image, the object that has been transformed, all my y-coordinates are the same. And you can probably see that, right? If I drew a line, let's see if I can draw a straight line, straightish line. If I took this line and I moved it around, you can pretty easily see, the y-coordinates for C are the same, the y-coordinates for D are equal, the y-coordinates for B are the same, As I place my horizontal line through corresponding points, you can see that the y value for all of these is the same. But the same cannot be said about the x values. That is what has transformed on all of these, okay? So when I reflected my object over the y-axis, my x values changed. So taking a look, this x value for A is negative 3.49. When I flipped it over the x-axis, it became positive 3.49. Or excuse me, flipped it over the y-axis, it became positive 3.49. And the same could be said for the rest. So all these, I'm in this second quadrant, all of my x values are negative. When I flipped this figure over my y-axis into the first quadrant, all the x values, the number is the same, but the sign flipped, okay? So again, by flipping over the y-axis, all my y-coordinates stayed the same, but my x-coordinates flip-flopped the sign. So if I'm thinking about mapping statements, well, what would it look like for a reflection? Well, that would be something like f of x, y maps to. For example, we just looked at a transformation where we had all of the x-coordinates, all the signs changed on my x-coordinates, right? So that transformation would look like this. Okay, and this is a reflection over the y-axis or across the y-axis, however you want to say it. This is a reflection over y. Now notice that this is not totally intuitive, right? Because you would expect that if we're doing something over y, you would think that it's the y variable that would be changed. But remember, since we're using y as the axis that we're flipping everything over, all of our y-coordinates stayed the same, right? So again, reflection over y means we have this negative x. Reflection over our x-axis, similarly, would be f of xy would map to something that might look like f of x comma negative y. Our y coordinates would be affected. So looking back at our, let's go back to our page. So looking back at our answer options, if we're just looking at f of x and x, so let me kind of clear up a little space here. Something like f of x maps to negative f of x minus 2 would be an example of a reflection, okay? And this would be a reflection over the x-axis because it's the y-coordinates that are being affected. If I look at this, remember f of x is basically y, right? So you can see that this transformation, this flip, is being applied to our y-coordinates. We have negative f of x minus 2. So I can see that this transformation is being applied to my y-coordinates. So this is a reflection. It's a reflection over the x-axis. Now they're not asking you to differentiate between these reflections, but it's just important to know that a reflection would either look like this, where we have a negative happening on the outside of our function statement, or it might look like that f with the negative in front of the x, something like, let me write it in a different color, something like f of x maps to f of negative x, okay? So those would both be examples, either having the negative applied to f of x or having the negative applied directly to x. Those are both going to be examples of transformation statements that include a reflection. Now remember, they just said include a reflection. It doesn't have to be a reflection only, and that's why this is, as I've kind of given away, this is going to be one of your answers, this statement. This x minus 2 part is a translation as well, so it's being reflected and translating, but the question specifically says includes a reflection, so we're allowed to include that in our answer choice. Okay, so one more time to wrap up, and I'll write it up here. Reflections will be of the form f of x mapping to a negative f of x, or f of x mapping to f of negative x. Okay, those are both going to be cases where we see reflections. All right, let's move forward. So next they ask you which mapping statements represent vertical transformations. Which mapping statements represent vertical transformations? So remember, vertical are things that are happening in the y-axis. So if we're just talking about translations and reflections, that could either be something like having a figure and then translating it upwards or downwards, right? It could be translated upwards or translated downwards. Or a reflection. Now remember, a reflection over the y-axis would not actually cause any y-coordinates to change. So if we're talking about a vertical transformation, it would have to be a reflection across the x-axis. So for example, if I had this shape and I reflected it across x, it might look something like, let's see, this. Okay? So I'm either looking for translations where my y is affected, or I'm looking for vertical transformations where I'm reflecting across the x-axis. So remember that if we're looking at mapping statements, this first one, translations up or down, is going to take a form that looks like this, where we'll have f of x mapping to f of x, and then it'll have plus k. Alright, so mapping statements that look like this are telling you that you're having a vertical translation, and that plus k is just telling you the number of units you're moving up. If you have a negative number, it's telling you the number of units that you're moving down. So that's one type of thing that you'll need to select. And then second, reflections across our x-axis. Okay, so remember, reflecting across the x-axis is going to change our y-coordinates, and a reflection across x might look something like this, where we have f of x mapping to f of negative x, right? Or excuse me, that's not right, f of x, sorry, mapping to negative f of x. So you can see the negative is being applied directly to f of x or y. So what this is doing is changing the sign of all of our y coordinates. Alright, so this is going to be our other one. So again, anything you see of the form f of x mapping to f of x plus k, or f of x goes to a negative f of x, these are all going to be vertical transformations. And our final question, it says, Digit is very good at transforming most functions, however, he is having trouble understanding how to perform phase shift on a periodic function. Explain what a phase shift is and how it relates to his previous knowledge of transformations. Alright, so notice the two parts of this question. So first explaining what a phase shift is, and then relating it to previous knowledge of transformations. So keep in mind a phase shift, if we're talking about a trigonometric function, which are the ones that have these kind of wavy shape like this. So a phase shift is when we take the whole thing and move it horizontally one way or the other. Right? So it's kind of like a translation. It's kind of like a translation in the x direction. So a phase shift of this might look something like this. Alright, where everything, the amplitude is the same, you can see it's hitting the same peaks and the same valleys, the slope is changing at the same rate. It's just that we've taken the whole thing, picked it up, and just moved it over a little bit, okay? That's a phase shift. So you have to explain what a phase shift is in your own words, and then you're going to see how it relates to previous knowledge of transformations. This you can interpret, there's not one particular way to interpret that, and I know that's a little vague, but you know, how I kind of compared it to translation, that might be one way how you explain or how you relate it to previous knowledge of transformations. As always, I'm just looking for a clear explanation, use of vocabulary from the lesson, and then I would say use an example to explain your ideas. That always helps and make sure that you're not missing any piece of your explanation. Alright, so I think that is the last one for that section, so that does it for this video, and I will see you guys next time.